Hello, hello. Is my voice is clear to everyone? हेलो हेलो बच्चों, कैसे हैं आप लोग? अगर मेरी आवाज़ आप तक आ रही है, हेलो, आवाज़ आप तक हेलो आ रही है, फाइन. Namaskar, Adab, Sat Sri Akal. How are you students? I hope that all of you are doing very good. तो हमारी कहानी कहाँ तक पहुंची? Till where we have reached, we have accepted the fact that okay, light is having a dual nature. Okay, at the end of the last chapter, that was matter and waves, we have at the end, after completing a long debate, that was a complete basically nothing but a story, okay, that we were started in optics, and we have seen that okay, firstly it was light, then it was a particle, because of photoelectric effect that we have discussed. So we have finally accepted the fact that okay, light is what dual nature. Sometime it will be having a nature of wave, sometime it will having a nature of particle. Okay, this is the fact that we have accepted. Now when we further move into modern physics, we have to study also about the minute particles from where, like atoms. Okay, so this branch of physics where we study about these minute particles or about the atoms, majorly you study about these chapters in chemistry. Okay, atomic structure is there in chemistry in PU1, if I'm not wrong. Swasar will be telling you more about it. So there in complete depth you study about these things. But in physics also there is some portion, because we have to discuss about the velocities terms, we have to discuss about the energies in more depth. We will be watching the energy spectrum also. So more of the things you study there also. There you more talk about the quantum numbers. Quantum numbers are there, if I'm not wrong. There are lots of equations, Schrodinger equation, and you call there as probability of having electrons. All these things are there in chemistry. Okay, but here we are majorly focusing on the radius, how we'll be calculating the radius, about the velocities and energies, all basic things that we used to talk about physics. Okay, we will be only in physics, we'll be watching the okay, what can be the possible closest distance of approach in any kind of if electrons are traveling, if you have thrown any electron towards it. So all these basic things I'm giving you the overview that what we are going to study. So this branch of physics is in that we study in physics is called as atomic physics. Okay, this comes under the atomic physics. That is also a modern physics portion, because this portion of physics is invented. It's very new still, I will say. Okay, so from where this atom word started. So let's again start from the beginning. Okay, let's, as we always start from the complete beginning and complete from the scratch. So today also, for this chapter also, I am going to tell you I am going to take you in 500 BC. In 500 BC, where firstly it was come to discussion, and that was nothing but no one other than, he was a Maharishi Kanad. He have firstly given something about atom. He have explained about the term atom, but term atom was not defined. He have said that, let's see what was the conclusion. What he said, that there a term Parmanu. He have taken a term Parmanu is an indestructible particle of a matter. What is Parmanu? Parmanu is indestructible. That means you cannot destruct it. This is that kind of particle that was given by Maharishi Kanad. When you divide matter into thin particle, ultimately we reach a stage when the matter cannot be divided further. So that stage, when you are keep dividing the matter, but you will reach at a certain state where you will not be able to further divide that matter. That means, is it true to say that that matter will be the smallest unit? Correct. And you know that enough chemistry you have studied. What is atom? We define as, now these times you are having more further like inventions we are having about quarks and rest of the things, but in our syllabus still we'll be taking that atom is the smallest unit, basic thing that we understand. Okay, so this was first thing. There is a complete series that we are also going to. Then in 442 BC, Democritus was there, and he has stated that matter consists of invisible particles called atoms and void. He have explained his own theories, but these things are not relevant. I'm just telling you about a little bit of history. Whatever is important will be starting from Rutherford model. More important is why Rutherford model fails. It was actually a good experiment, if I will tell you, in terms of the contribution towards this this portion of physics or chemistry, whatever you want to call this portion of science, I will say combined, Rutherford has a very good contribution. Okay, so that's why it is important for us also to understand firstly Rutherford model and why it fails. That gives the birth of Bohr model that we adopt also. Okay, that is the major thing from where questions also come in our syllabus as well. So obviously a Bohr model will be the most descriptive thing. Majority of the things we are going to study from Bohr's model. Correct? Very good. So now it actually starts from Dalton's. Okay, let's now start the topic from Dalton's. Okay, what Dalton says, all matter is made up of very thin particles called atom. Whatever the matter that you are having in your surrounding, all these things are made up of very thin particles, and that thin particle is called as what? Atom. Already it was concluded that it is the smallest unit. Smallest units means you already understand, so it was very obvious thing. What he said also, that atoms are indivisible part that cannot be created or destroyed in a chemical reaction. Okay, he further said that atoms are indestructible, same thing that Kanad said, that it cannot be destroyed. Okay, it is indivisible, but you cannot even further separate it in any kind of chemical reaction. This was the observation of Dalton. No new atom is formed, no atom is destroyed. He said that you not neither destroy any atom, okay, and not any new atom is also formed when he have performed an experiment, element 1 plus element b, he has given some compound C. This was basic thing about Dalton. He what he further said is, atoms of a given element are identical in a mass and a chemical properties. See, let's suppose these are the two bodies I have taken. Okay, so it will made up of a lot of small elements that what we are defining as atom. Okay, so I will say the mass or the behavior of one atom of this body will be exactly same from any other atom of this same body. They will be completely identical. If I'm talking about this will also have a lot of atoms. So one atom of this body, this pen, will be identical to all the atoms that are present in this pen. Okay, but if I'm going to compare the atom of this body and I'm going to compare the properties of this body, they will not be same. They will be different. That is what the basic is. And observation that he have given here, you can see that mass of atom A is also mass of atom B, same element, but when we have taken different element, mass of atom A and B here will be equal, C and D here will be equal, but it cannot be said that they are going to equal with each other, that A will be equal to C or D. Correct? See, now what are the next some things that he have observed? An atom consists of positively charged sphere with electrons embedded into it. An atom is a kind of sphere. It is a positively charged sphere where electrons are embedded into it. Actually, it should be embedded into it. Okay, that was another observation of Thomson's. An atom has as a whole electrically neutral because the negative and positive charges are equal in magnitude. What he further said, he said that an atom should be always electrically neutral because the magnitude of positive charge and magnitude of negative charge will be equal. Okay, these are the observations. According to J.J. Thomson, an atom was a solid sphere of positively charged material and then negatively charged particles. And the negatively charged particles, the electrons were embedded into it, like I have told you before. Like the seeds of the watermelon, the atomic model is compared to the watermelon. Actually, what he have did, he have compared this his own model with watermelon. How he have compared? Watermelon is a kind of sphere, you can say. And he have said that this complete watermelon is positively charged, and the seeds that you are watching here, na, that is randomly spreaded into this watermelon. These are the electrons that are embedded into it. So this was his observation. That is completely false. It's not like that. We know this day we know that what is a proper diagram of hand, what is the distance, exact, everything we have exact. So he have given everything random. Okay, but this is not the case. But still you have to appreciate it, because at that time we don't have that much of apparatus, not that much of devices to conclude the things. So a person who is thinking that much of far, you have to appreciate that. Yeah, doesn't matter it is correct or wrong. Okay, he have observed something that is in itself, it is a very big thing. That observation, doing that much of big observation is itself a very big thing. Okay, so we should appreciate always, but still it was not completely correct. Now, what are the limitations? Now understand here, limitations are more important, okay, because these limitations will give the birth of the next invention. See, what are the limitations? Failed to explain the stability of atom. Completely, he was failed to explain the stability of the atom. That was Rutherford also was not able to explain the about completely about the stability. Next thing, failed to explain how positive charge holds the negatively charged electrons in an atom. He have just told that randomly it is going to be embedded into it. Nothing he have defined that why it is random, where it will be there. So nothing will be explained about this also, that how that positive charge is going to hold all that negative charges. Okay. Failed to explain the scattering of alpha particle by thin particles by the thin foil. Thin foil, that was the next experiment. I told you na, that limitations always gives you the birth of the new invention. So he was also not able to perform the scattering of alpha particle. What is alpha particle scattering experiment? I hope that all of you would be knowing very well. Okay, this is very, so that experiment gives the birth of Rutherford model. Now Rutherford model is an important model. Okay, Rutherford model was very good. It's a very good. He have defined a lot of good things. Let's see. Firstly, you have to understand his experiment, that I hope that you are understanding from your chemistry knowledge also. What was the experiment? Firstly, you have taken a source of an alpha particle and he have thrown from that source. Let's suppose a laser gun he have taken that is throwing an alpha particle towards the end. Here he have taken a gold foil. What he have observed, he have noticed the in the trajectory of that alpha particle, he have noticed a lot of things. What he have noticed, that most of the alpha particle when passing through the gold foil goes undeviated, and it made it forced Rutherford to think about it. Actually, what is happening? Why it got undeviated? Most of the, not all the, most of the, some of the alpha particle got scattered. Some of the alpha particle got scattered. Let's suppose here is your, in front of your thin foil is there. Here it is a thin foil, and from here the alpha particle gold thin foil is there, and here from here alpha particles are coming. Some, most of the rays pass straight away, nothing problem. Some of them get scattered like this, some of them get scattered like this in all the directions, some of them get scattered like this, and very few of them get exactly come back on the same path. That means 180-degree reflection, can I say pure reflection happened for very few of them. Okay, so this trajectories of different alpha particles have given a lot of important collision conclusions. Okay, now what are those conclusions that build the concept of Rutherford? Okay, see, here it is very beautifully explained. See here, there is a gold foil that has been taken. See what is happening. Most of the alpha particle got passed without any deflection. Some of them got deflected or scattered deflected at some angle, that is the scattering. Some, and very few I will say, got returned back on the same path at 180-degree reflection, and some got deflected at some another angle. So this was the complete scattering that was observed. Now what is the meaning, what is the conclusion of this thing? That he have concluded that most of the area of an atom is empty. First thing he have said was what? That most of the area that is present in an atom is what? Empty, is an empty space. First thing. Second thing, a positive charge occupies a small space inside the atom. A positive charge is present inside the atom that occupies very less, because you know that. And what is alpha particle? Understand the behavior of alpha particle. I hope that it is clear to you. Alpha particle is nothing but helium plus 2. Okay, so it is having a positive charge, and why that was going past through it, why it is not getting stick to it, the reason for deviation was, you know that there is always a repulsion force will be there. Electrostatics now we know very well. Okay, if positive charge is there, that's why there will be always a repulsion. That means they cannot never get stick to each other. Okay, that's why some scattering was happening. Those who some were coming back again on the same path. Okay, and if it would be a negative charge, what will be happening? They both of them will get stick to each other very easily. They will get to stick to each other. But the reason of the scattering was telling that there is some positive charge that is concentrated at a point. Next thing he have said that there is a positively charged center in an atom called the nucleus. Nearly all the mass of the atom resides in the nucleus. From here the concept of nuclear model also come, and exactly what is our next chapter. Next chapter is about completely about nuclear physics, in which we are going to study about nucleus majorly. So the first time that a nucleus term is coming, not the term I will say, but the invention about that will be coming from here, that positive charge is there in an atom called as nucleus, and nearly all the mass is concentrated only at that nucleus. Rest of the most of the portion of an atom is just empty void. Next thing, the electrons revolve around the nucleus in a circular path. Further, he concluded that electrons that are present in an atom are not just randomly embedded, like Thomson have said. It is in a proper method, in a proper way, and it is revolving in a circular orbit. Problem with him was coming here only. Okay, he was not able to explain. I will tell you. Let's come to that also. Next thing, the size of a nucleus is very small as compared to the size of atom. That majorly we will be watching in nuclear physics. That is our next chapter. Don't worry for that. Okay. Now, next one, distance of closest approach. What is distance of closest approach? I guess this kind of question you have solved already. Just nothing, you have to perform energy conservation, you will be easily getting distance of closest approach. What is the concept? Let's suppose you have thrown any particle. I will tell you how. There is a variety of question also. I will tell you how these kind of questions are solving. Let's suppose you are throwing an alpha particle. You are throwing an alpha particle, and here it is a nucleus. There it is a nucleus. So what will happen? It is initially it is having some momentum, it is having some velocity. That's why it will going moving towards it. It will be moving towards it. But what will happen? It will be feeling some repulsive force also, because this is also positive charge, and this nucleus is also what? A positive charge. That means they will be feeling a constantly. They will be feeling a repulsive force, Coulombian repulsive force. And can you say if distance is increasing, force will be distance is decreasing, that means force will be increasing, keep on increasing, correct? That means I will say that repulsive force between them will be how much? It will be K ZE, that is the charge of the nucleus, and here it will be plus 2E divided by R square, and this R square is continuously decreasing. If this is decreasing, force will be continuously increasing, correct? So what I can say, force is increasing in repulsive direction, another direction. If velocity acceleration and opposite direction, I have told you what will happen. Body will stop, always this is the case. Body will stop and it will take a u-turn case from kinematics, correct? Whenever a mass and velocity and acceleration are in opposite direction, obviously there is always a case of u-turn. In SHM also we have proved a lot of times, so this is now familiar we are. So it will come, and finally somewhere velocity will become zero, and where velocity will become zero, it will take a u-turn and it will go far away. Okay, so this distance, that closest distance that have been approached, is called as distance of closest approach. Distance of what? Closest approach. How to solve this kind of questions? It is very easy. Nothing. See here. What is the concept? Just do energy conservation. Initial potential energy plus initial kinetic energy is equals to initial final potential energy plus of final kinetic energy. अब the initial potential energy पहले तो बताओ. If two charges are present, how you will be writing the potential energy? K Q1 Q2 divided by R potential energy. So you will be writing K. Let's suppose Q1 is writing for this one, Q2 I am writing for that one, and I will be writing distance. Initially it is at initial distance is always at infinite. Take it infinite. That means can I say it will become zero? Very good, it becomes zero. Initial kinetic energy, let's suppose it is given to you. Final potential energy, how you will be writing potential energy at this point? This is the final scenario and this is your initial scenario. How कैसे लिखोगे final potential energy? You will be writing K Q1 Q2 divided by what is the distance that is present there, that is R0, and finally kinetic energy, how much I will be writing? Half mv square. अब ये बताओ velocity कितना होगा? अरे of course ना, if acceleration and velocity are in opposite direction, that means velocity is becoming zero at this moment. So final velocity also zero. So from there only you have to calculate R0. Easily you can write that is equals to K Q1 Q2 divided by the kinetic energy. That's it. Nothing else. Correct. So this way you can solve all the questions of distance of closest approach. Okay. I hope that this will be clear to you. Fine. These are the observations that you will be reading by yourself. ओके रिसीवर नहीं लगा यार, समझ आ रहा है? क्या मास्टर बोर कर रहा है यार? बोलोगे यार तुम लोग मास्टर बोर कर रहा है. नाइस. अब काम करेगा रिमोट. हाँ, डिस्टेंस ऑफ क्लोजेस्ट अप्रोच बढ़िया. सॉल्व करो, सॉल्व इट. क्या आएगा आंसर? लेट्स सी व्हाट विल बी द आंसर विल बी कमिंग. करते हैं भैया सॉल्व. क्या दे रखा है? पढ़ो क्वेश्चन, रीड द क्वेश्चन. सी व्हाट यू कैन सी. When an alpha particle of mass m moving with a velocity v, यहाँ एक alpha particle दे रखा है moving with mass m and velocity v towards a heavy nucleus of charge Ze, towards a heavy nucleus is present charge Z into E, and Z तो पता है ना, atomic number is represented. Its distance of closest approach from the nucleus depends on m, as how the distance of closest approach is dependent with nucleus. देख लेते हैं कैसे होता है. Again, you will be writing going with the same method. U initial plus K initial is equal to U final plus K final. What will be the initial potential energy? I have told you always that it will be zero. Initially, it is at in some infinite distance. Initially, kinetic energy half mv square already given. Final potential energy is what you will be writing, that at some point its velocity will be zero, and at that point what will be the distance? That is called as exactly distance of closest approach. लिख लो, it will be K Q1. Q1, let's suppose here alpha particle, that means it will be plus 2e. Alpha particle have how much charge? 2e and plus, and this is the nucleus plus of Ze divided by what you will be saying, distance of closest approach. Final kinetic energy, it will be again zero क्योंकि velocity zero हो जाता है. So what you want to calculate? You want to calculate R naught. R naught will be going here, M will be coming here. So I can directly say, if I have to find only relation between the distance of closest approach and mass, I will say simply it is nothing but inversely proportional. That means option C is going to come correct. Clear? Badhiya. Very good. Very good. Now I will come to the failure of Rutherford model. What was the reason of failure of Rutherford model? Again, I will say it is more important than the complete thing, because failures always gives you new inventions. That's why we say that never afraid of failures. Okay. So actually the problem was coming when we have seen about electromagnetic waves. If you remember, electromagnetic waves is not very far behind that we have studied. It was a very recent topic. Electromagnetic wave, we have seen that whenever light propagates, okay, or any charge propagates, what happens when electromagnetic wave, actually if I will say propagate, electric field and magnetic field are oscillating. Electric field and magnetic field are oscillating in perpendicular direction, and we have seen that always some energy will be radiated. Always some energy will be radiated whenever there is an accelerated particle. I've told you, na, when charge is at rest, electrostatics. When charge is in motion, constant motion, velocity is equal to constant, acceleration is equal to zero, magnetism, we have completely understand. Then I've told you that now give this charge as acceleration, it will radiate some electromagnetic waves. That means some energy is radiated whenever an accelerated charge is moving. Correct? So the problem with Rutherford model was, obviously, if any charge is revolving in a circular motion of, always there is an acceleration. Without acceleration, how you can rotate in a circular motion? There is no possibility, because for making a circular motion, there is mandatory for having some centripetal force. Some centripetal force is mandatory. So it was clear that it is moving in accelerated motion. And the problem becomes now that if it is moving in circular motion and it is having some centripetal acceleration, it should be radiating the energy always. Correct? That means if it is radiating some energy, that means what should be happening with this electron? वैसे तो क्या होना चाहिए इस इलेक्ट्रॉन के साथ? It is losing its energy continuously, decreasing. Energy will be decreasing, and finally it should be colliding with the nucleus only. Finally it should collide with the nucleus. But what actually what was happening, that it was keep rotating in the same state, in same orbit. It was not colliding with the nucleus, and this thing was not, Rutherford was not able to actually explain, and Bohr at model have explained it. Nothing much he have did, I will say. It was also same kind of that's why I said that Rutherford model was very good. Bohr model was fine, very good, but he have also not did a lot of things. He just said one thing, that these orbits that are present here, no? These orbits that are present here are actually nothing but stationary orbits. He have given the term of stationary orbits. And what he explained, that these are that kind of stationary orbits. If an electron is revolving in these orbits, it is not going to radiate any kind of energy. Only when it is going to radiate energy, when either electron is getting excited or de-excited, either it is changing its orbit, then only it is going to be releasing some energy, and that also quantized. That will also will not be any random energy that it will be releasing. That is also a fixed band of energy that it is going to, if it is get that much of energy, it will be excited into a higher excited state, and if it is losing and it is going in de-excited state, that means it will be giving some energy in terms of photons. It will be releasing energy in terms of photons. This excitation and de-excitation terms, I hope that you will be familiar with, because you study a lot in chemistry about these kind of things. Okay, so this was the scenario. You can read it out completely for your board perspective, so these notes will be available for you. Okay, now let's enter into the board postulate, from where actually questions started. Okay, from where actually the questions will be coming. Let's understand three postulates were there. For both easy postulates, easily you will be solving. Only calculation, again I will say, you have to be very careful. Calculation part you will be handling, and rest of the things are very simple. Just wait a few minutes, you will be watching that. Some things, but some values you have to remember, that's it. See, Bohr's first postulate says what? Bohr's first postulate says an electron in an atom could revolve in a stable orbit without the emission of radiant energy. Exactly, that was the limitation, that it is moving in some stationary or stable orbit, and it will not radiate any energy. Second thing, you have said that each atom has certain definite stable state in which it exists, and each possible state has definite total energy. Each state, that means state means what I am saying, or orbit. All these orbits that are revolving, in which electrons are revolving, all of them are having some fixed energy. It is not like any random energy. So let's suppose, for example, if an electron is moving here, this is the higher excited state. This basic things will be clear, I hope. Let's suppose the energy of this one is 2 electron volt. Let's suppose energy of this one is 4 electron volt. Let's suppose energy of this orbit is 6 electron volts. So what will happen if this electron have to come in this lower orbit? What will be happening? When it is jumping from here to here, it will be releasing energy, and how much energy will be released? That is the difference of the energy levels of those two orbits. That means 4 minus 2, 4. That means 2 electron volt of energy will be released, and energy will be released in terms of what? Photons, because we know that we are very aware about the photons now. But let's suppose it have to be excited into the higher excited state. It want to move, it want to make a transition in highest excited state. That means it have to absorb some energy, and how much energy is required? That will be the difference between these two energy levels, that is equals to 2 electron volt. That is equals to 2 electron volt. This was what explained by Bohr, and in more depth we are going to see about when we are going to understand about the spectrum and those kind of things. Okay, अभी तो इतना ही समझो. So what he have said, that electrons are revolving in a circular motion. If electrons are revolving in a circular motion, that means it is a mandatory to have a centripetal force. And how that centripetal force is coming, now understand it. This is an electron, this is a positive charge, that means the nucleus. That means this electron will having toward the center always a Coulomb force. And what will be that Coulomb force? That will be K ZE into E, that is the electron, divided by radius r square. It is equals to, now this Coulomb force is acting like what? mv square by r. And what is mv square by r? mv square by r is the centripetal force for making any kind of circular motion. In फटे हुए speaker की तरह, always I say that there is mandatory some centripetal force, and here who is acting like that centripetal force? Here this Coulomb force is acting like that centripetal force. Correct. So this is equation 1. As remember, this is equation 1. This is what, because we'll be doing some derivations. Come to postulate 2. Postulate 2 talks about angular momentum. Okay, without angular momentum, what we have studied in rotation, that was equals to, represented as L, that is equals to mvr. Okay, so what he have explained about the angular momentum of an electron who is rotating in stable orbit. The angular momentum of an orbit of an orbiting electron is quantized. It is quantized. The angular momentum of electron in stationary orbits about the, it is integral multiple. It is integral multiple of h divided by 2 pi. How we define angular momentum? That is equals to mvr is equals to nh by 2 pi. That means it is the integral multiple of what? H divided by 2 pi. N can be 1, 2, 3 and so on. Okay. Third thing, that was a Bohr postulate that he have explained, was the energy of an atom has a definite value. That I have already explained you, that every atom has definite energy levels. In a given stationary orbit, the electron jumps from one stationary orbit to other. Let's suppose what is happening? Here is an electron and it is coming from E2 to E1. Here it is I hope that this is visible to you. It is coming from E2 to E1. If it is coming from E2 to E1, that means it is going into lower energy state. That means it is going to release some energy. And how much energy it is going to release? Here it is represented. It is equals to h mu. It is going to h mu. Let's suppose another electron is present here. Just the last example that I've explained. Again, I'm explaining the same thing. If an electron is present in here and it want to go into the next other excited state. That means if it want to go into the next other excited state, it will take some energy. That means energy will be absorbed. And how much energy will be absorbed? That is again equals to what? H mu. That is again equals to what? H mu. Okay. And how to calculate that how much energy is there? Just take the difference of energy levels. It's E2 minus E1 energy levels. And more further questions we are going to solve on the same concept. Hydrogen like atoms. All the derivations that we'll be doing here will be valid for all the hydrogen like atoms. Bohr model will be explaining about the hydrogen like atoms only. It is not explaining about the different element like combined let's suppose two multiple, if let's suppose two atoms are there, then what will be happening? Then that kind of things, then we'll be talking about bands, not a single energy level. Then we'll be talking about bands because they will be overlapping. All these things we study in the next chapter, or the next chapter I will say properly, semiconductor and devices. That is, there we'll be understanding the behavior. Okay, so those things are not explained in, so only we are going to study what? Hydrogen like atoms. Hydrogen like atoms means what? Single electron. That means I can say lithium also, lithium 2 plus, single electron will be there. Beryllium 3 plus, boron 4 plus, all these things will be having single electron only. Okay. Now first formula that I will say formula only, that first formula that you have to remember is the radius of the nth orbit in which electron is revolving. How you will be deriving that? Derivation is anyways not at all important, just for board perspective I'm telling you. Otherwise you just have to remember the values, and in the values also you have to remember the proportionality. Proportionality is the most important, most important thing. Number of star marks you want to add, just add it. Okay, see, first equation what you will say, mv square by r is equals to kz e square divided by r square. Okay, first equation, that if electron is revolving in a circular motion, what you can say, that it will be having a Coulomb force that is acting like a centripetal force. That is the first equation. Second equation what you have said, that mvr is equals to nh by 2 pi. Mvr is equals to nh by 2 pi. So from here I got two equations. From here what I can say, this r will get cancelled, and from here what I can say about r, that it is equals to kz e square divided by mv square. That's it from the equation 1. That means what is a variable? Only I know k value, I know z for hydrogen like atom, I know e square, I know the mass of electron as well. What I don't know is about the velocity. So from here I can say velocity from the second equation, I can write it as what? nh divided by 2 pi into m into r. Now put this velocity term here, put this velocity term here, and then when you will solve it completely, putting all the values. Now it's a very bad calculation, that's why I have told you that you don't have to enter into this. Okay, just remember the values and just move forward. So what is the final value? That is the most, see this kind of values that will be coming. H square itself is a very bad value, and you have to do h square, 4 pi square, k into e square into m. I am not entering into that. If you want, if you have the guts, please do it, no problem. So what we'll be saying about the radius of the nth orbit, that is equals to 0.53 into n square by z. And what the radius is coming in, that is important, that it is coming in terms of angstrom. It is coming in terms of angstrom. Most important thing that you have to remember from here, this radius in nth orbit is directly proportional to n square by z. Radius in the nth orbit is directly proportional to n square by z. Second thing more to remember, that is it is calculated in terms of angstrom. Radius of the electron. Okay. Now let's come to the before that there is a basic question. See what is the question? Just a formula application, nothing else. Find the radius of lithium plus plus. Lithium plus plus, why it is written? It will become now again a hydrogen like atom. And in ground state, assuming Bohr model to be valid, you have to calculate radius. Radius is what? 0.53 n square by z. Now 0.53 will be, as it is n square. N square will be what? In which state it is? N is representing what? N is representing the state in which it is present. Ground state. Ground state means n is equal to 1 divided by z. Z, what will be saying for lithium? Lithium will be having 3. Hydrogen, helium, lithium. Atomic number 3. That means Z value 3. Just solve kar lo. You will be having a radius, and here answer is given. It is equals to 0.176 angstrom. Simple. I just have told you that how to put the values. Okay. Second thing is velocity. How will be calculating the velocity? So velocity कैसे calculate करोगे? Radius already you know. Second thing that you know from where, that mvr is equals to nh divided by 2 pi. So from here what you can write for velocity? Velocity you can write nh divided by 2 pi m into r. And from the first case only you know what is the radius. Radius will be this much only. Put the radius, again you will have a very bad, very extremely bad calculation. The results will be looking somewhat like this. If you want to remember this is up to you. But after solving the result is very important. The result is what? 2.18 into 10 power 6. Velocity in the nth orbit of the electron is equals to 2.18 into 10 power 6. This is the magnitude in, and then it will be z by n. Z by n. This is the another thing that is very important. And then it is calculated in meter per second. It means it is calculated in standard units. These many things you have to remember. काम हो जाएगा. All the questions you will be able to solve. Correct. If you want to remember, you can remember one more important thing, that mass in the radius formula, in the radius one, if you notice that how that is proportional to the radius and the mass of the electron, that you can say here that it is inversely proportional. Okay, because one time a question was asked that if there is mass of electron, where it will be lying. Here it is the radius and here it will be the mass. That is inversely proportional. Okay, very good. If you have to calculate time period, how will be calculating time period? Easily. Radius, you know what you can say about the radius. Radius is this much. Velocity also you have calculated. That means how you will be writing time period. Time period you can write directly 2 pi r, that is the time, that is the complete circumference, divided by the velocity, that will be the time in form of distance divided by speed. And when you will be solving, again you will have this much of the things. But is important to remember that already only you know. Tell me, radius is proportional to what? N square by z. Correct now? N square by z. And what is the velocity proportional to? This is proportional to z by n. So when we will be taking the net proportionality, because the questions will be majorly that will be coming will be from proportionality only. They are never, rarely some questions will be coming where you have to quote the exact values. Majorly questions from this topic is coming from ratio kind of. So you can say in ratio only proportionals are important. So it will be net, you can say it will become n cube divided by z square. Time period is proportional to n cube divided by z square. Correct? Fine. Now come to the energy. Energy also, first energy that you have to understand, that is kinetic energy. कैसे calculate करोगे? Very basic thing. Kinetic energy is equals to half mv square. V में वो पूरा का पूरा टर्म उठा के पटक दोगे तो क्या होगा? Finally when you will be solving, you will be having this kind of value, that half kz e square divided by r square. Correct? Now see. So when you will be putting all the values, the final result that is important is kinetic energy will be equals to, क्या हुआ? Final result that you will be having is kinetic energy is equals to 13.6 z square divided by n square. Z square divided by n square in electron volt. That is two things what are important. That it is calculated in electron volt, and what is the proportionality of kinetic energy? It is proportional to z square divided by n square. Z square divided by n square. Now if I will tell you, do you know the relation between total energy, potential energy and kinetic energy? याद है किसी को? Anyone? It is very important relation. It is valid in gravitation. First time you will be studying in gravitation, then SHM, then electrostatics, then in magnetism also there is a discussion about it. So a lot of places you study about it. And again, I will tell you again. I'm going to tell you in nuclear physics also. I'm going to again tell you about this relation. This is valid at every place. What I'm trying to tell you, that kinetic energy is equals to, yeah, I will say kinetic energy by 2 is equals to potential energy is equals to total energy. And you can apply mod as well. You can apply mod as well. या उल्टा लिख दिया यार. See, कोई दिक्कत नहीं है. See what you will be doing. Remember what was in gravitation? Potential energy. What you have written? The potential energy. Potential energy you have written minus of gmm divided by r. What you have written? The kinetic energy. Kinetic energy you have written gmm divided by 2r. And what was the total energy? Total energy was the summation of this, and it was equals to minus of gmm divided by 2r. gmm divided by 2r. So what you can define, यहीं से derive कर लो relation, that mod of kinetic energy is equals to the mod of total energy. अरे mod लगा दिया तो बराबर हो गया ना ये दोनों, correct? And what I can say, if I am multiplying 2 times in kinetic energy, I will be getting the potential energy. So I can write this also as potential energy by 2. This is the equation that you always have to remember. And remember that total energy and potential energy will always be taken as negative. It will always be taken as negative. So if you know the kinetic energy here, can you write all the energies? It's up to you, yeah. If you want to derive it, you can do. No problem. But we should apply some brain also. If I know that kinetic energy that I have from hard work, I have calculated that it is equals to 13.6 z square by n square. What I can say about potential energy? Potential energy, what you will be doing? Just potential energy, if you want to calculate from here, you have to 2 times multiply the kinetic energy, and it will be how much? It will be 27 point, कितना हो जाएगा? 27.2, correct? 27.2 z square divided by n square. And if I will ask you total energy will be how much? Total energy is equals to kinetic energy, but the polarity, the sign will be changed. That means minus of 13.6 z square divided by n square. And of course that will be the final result. Let's see. See, potential energy also you will be deriving from k q1 q2 divided by r. Now you will be putting the radius formula, radius value there. When you will be putting the radius, again you will be solving the complete thing, putting the values. Then you will be having potential energy is equal to minus of 27.2 z square divided by n square. And when you will have the potential energy, then you will have the kinetic energy. What will be not kinetic energy, total energy. Total energy will be equals to the potential energy plus kinetic energy. So जब calculate करोगे तो at the end again you will be having the result as minus of 13.6 z square divided by n square and calculated in electron volts. And again that relation will be still valid, that total energy is equals to minus of kinetic energy is equals to potential energy by 2. Very important. This relation is very important here. It is applied in all the chapters. So please remember this relation. Very important. It can be used at a lot of places. Okay. Any one relation, if you know, you can create the relation for other things also from that relation only. Okay. So it is a useful thing. See. So it was fine. Now let's define the energy. We know the total energy of any state. If I know the value of n, I know what kind of atom it is, I can define the energy of any kind of level. Let's start defining energy levels. I will say that remember the energy levels till n is equal to at least 4 or 5. Okay, according to me, if you will ask specifically if you are a NEET student, you have to remembering the values till n is equals to 4 at least, the energy levels. How you'll be calculating? Let's see also. Let's see one by one. We know the formula now, so we can calculate it easily. Let's suppose for n is equals to 1, I want to say that how much the energy, that is what will be the energy of this level. I will be simply saying, sir, energy is equals to minus of 13.6 z square divided by n square. Now minus of 13.6 z square will be what? Z will be what? It will be we are calculating for hydrogen. We are calculating for hydrogen atom. Hydrogen atom, that means Z is equals to 1, and n is equals to ground state, that means n is equals to 1. That means can I say energy of this level is nothing but minus of 13.6. Correct? Let's calculate for 2. Let's calculate for this one. What I can say, energy is equals to minus of 13.6 into z square, it will still 1, and it will be divided by n square, that is 4. That means 13.6 divided by 4, how much it is? minus of 3.4. Energy of the second level you can define. Let's suppose you want to calculate the energy of the third level. Again, do the same thing. Minus of 13.6, z square will be still 1 divided by n square. N square for this level will be divided by 9. And you can say it will be, I don't remember because it is not of my use. I used to calculate it. Okay. So for problem solving, better if you are removing the results. And if our electron is making transition, it will be actually helping you where they will not ask you that tell me the energy of this level. When electron is making transition, I have told you that whenever electron is making transition, you have to take a difference of the energy, higher energy minus lower energy state. So let's suppose an electron is making transition from here to here, from this energy level to this energy level. What you will be understanding that it is going to release energy, and how much energy it is going to release, that is E2 minus E1. Take the difference, that is minus of 13.6 minus of or in magnitude if I'm talking 13.6 minus of 3.4. If you know the energy levels easily, you can tell me that how much energy will be released. Still people remember some energy change, difference energies also between the first and second and third. These energy also lots of people remember, but still I'm not telling you about that. If you know this much of also, you can even approximate the options, so you will be sufficiently able to solve the questions very fastly. Okay, let's see, let's have a question. What is the question is saying? The total energy of an electron in an atom is in an orbit is minus of 3.4. टोटल एनर्जी दे रखा है, कितना दे रखा है, इतना दे रखा है, इतना कितना, minus of 3.4 electron volt. Okay, its kinetic energy and potential energy you want to calculate. कुछ नहीं दे रखा है, just total energy is given. You have to judge what will be the kinetic energy and the total potential energy. So what I have told you that kinetic energy is nothing but equal but change in sign. That means 3.4 plus of 3.4 electron volt low. ये तो हो गया. Potential energy is what? Potential energy is 2 times of kinetic energy. You can say that means just multiply it. It will become 6.8 electron volt but with a negative sign. That means check which option is coming correct. 3.4 and 6.8 minus of 6.8. I guess option D should be coming correct. Option D is coming correct. Is it clear? Otherwise you would be solving that much and then you will be finally somewhere you will be getting your result. So it's a much better, relatively much better method. Correct now? Now let's understand little bit about spectrum. Hydrogen spectrum. What kind of hydrogen spectrum that you will be having? You know that whenever there will be transition of electrons, some energy will be released, and how much that energy will be released, that is equals to, I can write that energy is equals to hc by lambda. In terms of photons it will be released, that means I can write hc by lambda, and according to that lambda I can create a spectrum. That you know that every color have different wavelength. So according to that wavelength that you are going to get, according to that I will have different spectrum or different colors that will be observed on a screen. Okay, so that is what we are going to understand. Let's suppose what will be the in general equation. Let's suppose it is making a transition from one excited state to another excited state. What you'll be saying? You'll be saying, sir, when it is making a transition from n2 to n1, what you will be saying, how much energy will be released, that is equals to hc by lambda. It is equals to, I can say, minus E2 minus E1, correct? What is E2? Minus of 13.6 z square divided by n2 square minus of 13.6, it is z square divided by n1 square. Now it is what? This will also be negative, so negative will become positive. Take the commons out. 13.6 z square, rest of the things will be inside. It will be n1 square minus of n2 square. It is equals to what? hc by lambda. This is the result, in general result, whenever a transition will be happening for an electron. This is the formula that you have to apply. मैं तो इससे भी शॉर्टकट बताता हूँ. Okay, don't get confused ever for n1 and n2. Always put n1 smaller one and n2 always bigger one. Simple. Don't get confused. Always put n1 smaller one and n2 bigger one. Always you will be having the correct answer. You can check it also. बता रहा हूँ मैं तो. ठीक है. There is one more way to remember the same result. What is that way to remember this result? What is this hc? This hc, when you put the values, okay, this actually equals to 12,400. So when you will be putting this, it will become 1 by lambda. Take this hc here. Take this hc here, that 13.6 divided by hc. into z square 1 by n1 square minus of 1 by n2 square. This value completely make a term, a constant, that is equal to Rydberg constant. If you remember, this is equal to Rydberg constant. So this formula standardly also remember as 1 by lambda is equals to rz square 1 by n1 square minus of 1 by n2 square. Correct? And this will be calculated in standard units, so it will be calculated, actually it is 1 by lambda, so it will be meter inverse. So when wavelength will be calculated, that will be calculated in meter. About Rydberg constant, this is the Rydberg constant. What is the value? 1.096 into 10 power 7. This is an important value that you have to remember. Rydberg constant is 1.09 into 10 power 7. भाई मुझे इतना constant से याद नहीं रहता भाई, you have to remember. Okay, 1 by lambda is equal to r into z square divided by 1 by n square 1 minus 1 by n2 square. Correct? So wavelength calculate करने के लिए it is much better formula, because again I will tell you that ratio kind of questions will be coming. Whenever ratio kind of questions is coming, you just have to check the proportionality. R will always be getting cancelled out, and the rest of the questions you can easily solve. Like here. What is the question? Let's see. Calculate the wavelength of radiation emitted when helium plus makes a transition from n is equals to 3 to n is equals to 2. कैसे लिखोगे? Let's apply the formula. What is the formula? 1 by lambda is equals to rz square 1 by n1 square minus of 1 by n2 square. This is what our basic formula. So what you can say, 1 by lambda is equals to r value is given, you will be putting this value. Z, what will be saying? Z value for helium is 2, that means square when you are making it will become 4. 1 by n1, I have told you always put the smaller one before. Smaller one is what? 2, that means here it will become 4 minus of 1 by n2 will become 3, that means here it will become 9. Eventually it will become what? 9 minus 4, that means 5 by 36. 5 by 36, r into 4 into 5 divided by 36. This 4 and this will get cancelled, and lambda can be written as 9 divided by 5r. Lambda can be defined as 9 divided by 5r. Value put कर लेना है, जो भी आंसर आएगा you can check. 9 divided by 5r exactly. Correct? After that you can just put the values and check what the final result will become. Clear now? Now see about spectral series of hydrogen. Okay, one basic thing I have to tell you. What is the hydrogen spectrum? If I will tell you completely, understand here. I'm drawing the diagram. This is called as the ground state. N is equals to 1. Whenever anyone says that it is the ground state, that means you will put what? N is equals to 1. Second one is called as N is equals to 2, and it is called as what? First excited state. First excited state means what? N is equals to 2. Then you will have n is equals to 3, second excited state. Then you will have n is equals to 4, next excited state. Then you will have n is equals to 5, next excited state. This way energy levels are there, and already we have defined the energy of all these levels. So what is the spectrum that it will be lying? I have to tell you that the first line that will be coming here, first transition will be from n is equals to 2 to n is equals to 1. Then what will be the next transition? 3 to 1, then 4 to 1, and I should draw an infinite. N is equals to infinite line also somewhere here. This is n is equals to infinite. So the final line that will be coming here will be what? The final line that will be coming here will be from infinite to 1. All these series that are coming here, when the n value is equals to 1, this is called as what? Lyman series. This is called as what? Lyman series. Next spectrum that you will get till n is equals to 2. Firstly from 3 to 2, then second line will be from 4 to 2, then 5 to 2, then finally what it will be? Infinite to 2. This series is called as what? Balmer series. This series is called as what? Balmer series. Next series till n is equals to 3. First line, this is the second line. Final line will be what? From infinite to 3. This line is called as what? Paschen series. This line is called as what? Paschen series. And after that again bracket and p fund are also there, but that are not that much important. These three are most important from where questions can be asked. And now what kind of questions will be asked? They can either ask you from the energy related questions, either they can ask you from the like this kind of questions. This first line is called as what? This is called as first line. This is called as first line. This is called as first line. This last line is called as series limit. Series limit. So they will ask you in terms of that, tell me what is the series limit, wavelength of the series limit, wavelength of the first line. They will ask you either in terms of, tell me what is the minimum wavelength that you will be having, or they will ask you in terms of maximum wavelength. Always remember, if the gap is more, wavelength will be less. Simply, if the gap is more, wavelength will be less. So if I will ask you an interesting question, tell me, transition from 2 to 1 will have higher wavelength, or transition from infinite to 1 will have higher wavelength? Which one will be having higher wavelength? Lagao dimag. What I've told you, when gap is more, wavelength is less. Gap is more, wavelength is less. That means I can say wavelength will be higher from n is equal to 2 to 1 as compared to transition of n is equal to infinite to 1 of the Lyman series. So it is तरीकों के questions जो हैं that actually get framed. Now let's understand this in here. See, here lines are drawn very perfectly. Initial state will always, for Lyman series, initial state will always, the final state will always be 1. Whatever the transitions will be happening in the Lyman series, it is always reaching to 1. Now it can be done from 2, 3, 4, 5 and still to infinite. Okay, that is the one thing. Wavelength, how you will be calculating? 1 by lambda is equal to r 1 by 1 square. Always I have told you. Minimum wavelength and maximum wavelength you will be knowing. And this range, the Lyman series that is there, the wavelength that will be coming will be lying in the UV region. This always lies in the UV region. ये भी याद रखना. In which region it will be lying? Specifically, I am telling for NEET students. Next series is Balmer series. Balmer series, always the destination will be what? N is equals to 2. कहाँ पे आके रुकेगा? N is equals to 2 is the final destination, and it can come from 3, 4, 5, 6 and so on after that. Okay, same way you will be calculating the wavelength for this also, but it is lying in the visible region. That is important. It is lying in the visible region. Same you will be doing for Paschen series. Paschen series, what is the final destination? N is equals to 3, and then when from where the transition can be starting from 4 to 3, 5 to 3, 6 to 3, and these kind of transitions are possible here. Next one, bracket series. Bracket series, final destination is 5. Paschen series, it is lying in infrared region. Paschen series is lying in infrared region. That is one more important thing. Okay. So these kind of things that you can understand here. Clear? Next term is ionization energy and potential. Potential will be the related with the energy. Whatever the ionization energy, you will be defining that with the potential. What is ionization energy? The energy required to take any electron from the ground state to n is equals to infinite. That is called as what? Ionization energy. So how much you can define? The minimum energy required to move an electron from the ground state to n is equals to infinite is called as ionization energy. For example, what you can say, energy is written as 13.6 z square. If I am calculating for hydrogen, I will write z square as 1 divided by 1 by 1 square minus of infinite, because starting is always from 1 to infinite. If you are taking this, will become 0. That means energy for ionization energy for hydrogen like atom will be equals to 13.6 electron volt. If I'll ask you for helium atom, that means z square only becoming 4. Just multiply 13.6 with 4, you will be having an answer. Correct? So what is the potential difference? It is not connected. You know that relation that Q is energy is always written as Q into delta. So from what is the potential difference through which electron is accelerated? That is defined as what? Ionization potential. So ionization potential, how you can define? This is the ionization potential, ionization energy, it is written as Q into delta V. This is ionization potential. So ionization potential can be written as ionization energy divided by the electron. That's it. Okay. And next one is excitation energy and the potential that is taken with that. What is excitation energy? Energy required to move the electron from ground state to any other excited state is called as excited energy. If you want to take an electron from ground state to any other state, you have to give it energy. You can feel it now when it have to move in higher excited state, you have to give energy. If it is coming from higher excited state to lower excited state, then it is already releasing its energy, because what happened, actually it comes to its stability. For gaining any kind of stability, you have to decrease your own energy. When you will be at minimum energy level, then you will be at the stability. Okay, you can relate with your practical life also. Okay, that when you get all of tiredness and the rest of the things, then you got finally that, okay, now I want to sleep only, then you got your stability. Okay, so when you are with minimum energy, you will be getting your stability. Okay, that is the basic thing that you already study in chemistry also. Okay. So again, excitation potential will be defined by the same way, excitation energy divided by the electron. From electrostatics, we are studying about this thing. What is binding energy? Binding energy is, if binding energy is what? It is that energy who binds all the electrons in this system. These electrons are revolving. That means they are attracted by some force, and if there is some force, there will be energy. By what it is getting binded? What is the minimum? And binding energy you have studied in gravitation also, yeah, same gravitation also. So the energy that is required to bind all these electrons into that circular motion, that energy is called as binding energy. See, what is the definition here? Binding energy when constitutes of a system are brought from infinite to assemble the system. Binding energy is negative of the ionization energy. If all the to bind, let's suppose all the electrons are lying at some infinite distance, to take all those electrons from that infinite distance to some finite distance to make it a complete system, that energy is called as binding energy. It is exactly opposite to the ionization energy. What is ionization energy? Ionization energy is to taking the electron from the ground state to some infinite excited state, to some infinite state. That is ionization energy. What is binding energy? Binding energy is taking an electron from some infinite distance to bring it to n is equals to 1, that is a ground state, that is called as what? Binding energy. So if you are going with for the formula, just take a negative sign in that, that's it. That will be done doing your job. Okay. See, what are the limitations? The limitations will become now a new chapter for you, that is semiconductor and devices. Limitations are could not explain the splitting of spectral lines in electrical and magnetic field. When it was entered into electrical and magnetic field, he was not able to explain the spectral lines. Failed to explain the atomic spectrum of atoms other than hydrogen and hydrogen like atom. It was other than, it failed to explain, this model failed to explain that other than hydrogen like atom, when 2 electrons will be there, 3 electrons will be there, then what will be happening exactly? Then this what I told you, term overlapping, the overlapping of the energy levels will be happening. Then what kind of things we discuss, that is in semiconductor again. Couldn't explain the ability of atoms to form molecules by chemical bonding. Yes, thoda chemistry ka hai, this Suhar sir you can ask. Okay, so let's practice some basic questions and try to understand how to apply the formulas actually. Let's see what is the question. पहले तो question पढ़ते हैं. If an electron in an hydrogen atom jumps from 3 to second orbit, it emits a photon of wavelength lambda. It emits a photon of wavelength lambda. When it jumps from 4th to 3rd, corresponding wavelength will be. When it is jumping from 4 to 3, then what will be the lambda dash? Fine, solve कर लेते हैं. करें? See, take the first case. What will be saying? 1 by lambda is equals to r into z square. Z square again it will become 1. 1 by divided by, again छोटा वाला सबसे पहले, that means smaller one you will be taking first. It will become 4 minus 1 by 9. Correct? That means what you can say net about 9 minus 4, that means 5 divided by 36 r. That is lambda. Second equation, 1 by lambda dash. For second case, what will be defining? The transition is from 4 to 3, that means you will be writing 1, it will become 1 by 16. Here what you can say, it will become how much? 16 minus 9. 16 minus 9 कितना होता है? It will be 7 divided by, here it will become 144 into r. Now take the ratio. When you are taking this ratio, 1 is to equation 1 is to equation 2. What is the ratio is going to come? This will become lambda dash divided by lambda is equals to r cancel. Actually r cancel, and here 36 it will get cancelled. कितने बार में cancel होगा यार? It will cancel at 4 times. This 4 will be going upside. This will become 20 divided by 7. 20 divided by 7, that means lambda dash can be written as 20 divided by 7 times of lambda. Any option is there? 20 by 7 lambda. Option C. Correct. This way you will be applying. Just remember that. Don't get confused. What is will be n1, what will be n2. Just simply. Smaller one, smaller orbit you will be firstly you write, and the higher orbit you will be secondly just write it. Okay. Calculate this one. The ratio of wavelength of the last line of Balmer series. What is the last line of Balmer series? Last line of Balmer series is from infinite, and final destination for Balmer series, what I've told you, that it is 2. Ratio, let's suppose this is lambda 1, and then you have to take the last line of Balmer series and the last line of Paschen series. Last line of Paschen series, that is infinite to 1. It is very simple. Let's suppose it is lambda 2. What you can say for lambda 1? Lambda 1 r z, all these things will be cancelled. It will be only what? It will be 1 by 4 minus of 1 by infinite, and here it will be 1 by 1 minus of 1 by infinite. That will be 0. That will be 0. Here it will be what? Lambda 1 by lambda 2. Lambda 1 by lambda 2, it will become 1 by 4. Correct now? The ratio of wavelengths of the last line of Balmer series and the last line of Lyman series. Last line of Lyman series will be coming to 1 from infinite, and it will be coming to, that means lambda 1 by lambda 2, it will be equals to, here it is already 1 by 4. Correct, it will be 1 by 4 only. It is r by 4, correct. Correct na yaar. It is 1 by lambda, no? Correct, exactly. 1 by lambda 1, no? 1 by lambda 1, it is from infinite. For last line of Balmer series from infinite to 2. That means it will become 1 by lambda 1, it is equals to rz square, again going to be cancelled. It will become 1 by 4 minus 1 by infinite. Formula is what? 1 by n1 square minus of 1 by n2 square. If you want to write the formula, here it is the formula properly, you can write rz square 1 by n1 square minus of 1 by n2 square. And for Balmer series, what is the final destination? It is always equals to 2. And last line, that means it is coming from infinite. That's why I put it these many values, and it will become 0. Next one, 1 by lambda 2, or let's write it is for Balmer, this is for Lyman. This will be equals to what? It will be 1 by 1 minus 1 by infinite. It will be 0. And now when you take the ratio of equation 1 and equation 2, it will become lambda L, that means lambda of Lyman series divided by lambda of Balmer series, it will be equals to 1 by 4. But we have to calculate the, I was calculating this ratio, but we have to calculate the lambda of Balmer series divided by lambda of Lyman series, that will be equals to 4:1, or answer can be written as simply as. समझ आया? Is it clear? I hope that you have enjoyed this session. Okay. Most of the portions we have covered. The rest of the things, it will be clear into the question series when we will be having. Okay. So if still you are having any doubts, please don't hesitate to comment down into the comment section all your doubts. We are waiting for your doubts. We will be completely regularly reactive to give the responses. Okay. So until next time, keep learning, keep growing with Tapasya, Endigu, and Dendigu, Nama Tapasya.